Well, we certainly saved the best for last for this one. This one is a bit of a bear. I have two exponentials set equal to each other, and I want to solve for whatever that x is. And let's just think about what this means for a second. There's some value for x that when I add 2 to it, and it becomes a power of 3, it'll equal 2 to the 1 minus that same number. This is kind of hard to believe that this is even possible, but in fact it is. We can approach this in a couple of different ways, and probably the easiest would be to use our graphing calculator to plot the two equations, y equals 3 to the x plus 2 and y equals 2 to the 1 minus x, and then graph it and use the calc intersect function to find our intersection. And that gives us our intersection, that gives us our x value, and we can actually even find whatever that y value is too if we were interested. This is the easiest way to do it, I would say by far. You have to know how to press a few buttons, but let's also talk about the algebraic approach that we could take as well. What I'd want to do here is if I wanted to solve for x, I know that I'm going to need to use a logarithm since x's are in the exponent. And so what I'm going to do is I'm going to take the log of both sides of this equation. So I took a log with base 3, so log base 3 of 3 to the x plus 2 equals log base 3 of 2 to the 1 minus x. Now really, it doesn't matter which base you choose. I did choose 3 for a strategic reason, and I think you'll see why in just a second. Once I use that power property, I'm going to move these exponents into the front of my logs. So I get x plus 2 times log base 3 of 3 equals 1 minus x times log base 3 of 2. We know that log base 3 of 3 is equal to 1, so this just becomes x plus 2 equals all that stuff over there. All right, now we're pretty much ready to solve for x. I have no x's in any exponents. I just need to do a little bit of algebra here. So what I'll do first is I'll distribute that log base 3 of 2 into that binomial, so that I have x plus 2 equals log base 3 of 2 minus x log base 3 of 2. I want to get the x's all together. That's my goal here. So I'm going to do a little bit of manipulation here as well. I'm going to add x log base 3 of 2 to move it to this side, and then I'm going to subtract 2 from both sides to have a minus 2 over here. So basically I just got all of my x's together and all the other stuff on one side. Now that I have these x's together, I want to group these x's somehow. So the way I can do that is by factoring. I can pull an x out of this binomial so that when I factor out this greatest common factor, I have 1 plus log base 3 of 2, and that's still equal to this right-hand side. All right, now I'm almost there. I got to get the x by itself. It's being multiplied by this quantity, so I'm going to want to divide by this whole quantity. And I get x equals log base 3 of 2 minus 2 over 1 plus log base 3 of 2. Now, as a little side note, I could actually make this into one log if I really wanted to put forth the time and energy to do so, but I think it would be best to, at this point, go to an approximate solution. I'm just going to type this in to my calculator, log base 3 of 2 minus 2 all over 1 plus log base 3 of 2, and that comes out to be negative 0.839444157, all that stuff. I'm going to approximate this out to 4 decimal places. So I have x is approximately equal to negative 0.8394. So this is a bit of a tricky problem. Hopefully you see why I chose a base of 3, because that was able to get me to cancel out this log base 3 of 3. Another good idea could have been to use log base 2. That would have canceled out a log base 2 of 2 over here. It really doesn't matter how you slice it. You'll get to the same answer anyways. This approximation should be what you get no matter what. You can even take the natural log of both sides, but I wouldn't recommend that. Why don't you try this example here? Similar to the last one, pause the video, give it a shot, see if you can't work it out. And here's my solution. This all comes out to be 1.0202.